So today's video has a bit of a seasonal vibe for summer 2026. I'm just quickly placing one last end plate on the other side, and I think you've already spotted it. This is a soccer goal. A bit unusual since it's built from steel profiles, but hey, it should definitely be solid. SolidSteel has, of course, remembered the values from the previous connection, so I can just confirm. And there's the end plate. And that completes the steel structure. That's what it looks like from the back. Now it just needs a net. I created one here using sketch lines. Yep, now the game could start. Alright, jokes aside, even though no one would really design a soccer goal like this in real life, it's still a clean model, and that means subsequent workflows run just as cleanly too. So let's take a look at that now. First, we automatically assign position numbers. At the same time, equal part detection is performed, which means geometrically identical parts receive only one position number. Next, we run a metadata update. That writes all information into the parts, and then we're ready to generate a bill of materials. We can define what the BOM should look like right here in the dialog. I'll choose the full bill of materials and set the header to English. Then we select an export path and file name. And with one click on the green checkmark, the export runs. Once the icons up here turn colored again, the export is done. Let's check the result. Here's our Excel document with multiple sheets. The quantity list, the sheet list sorted by plate thickness, the beam list sorted by profile type, the structure list where we see all assemblies and welded assemblies, the saw list including cut angles, and finally the bolt list. So that's all the construction data you need, automatically compiled, always up to date, and reliable. Let's stay with classic steel fabrication for a moment and export shop drawings. The correct menu is Drawings, and then Drawings again. We get a message saying a position number update should be run first, but we just did that and haven't changed anything since, so we can click No. Now the Drawing Assistant opens, the central drawing management tool and SolidSteel parametric. I'll only do a quick pass here, feel free to watch the full in-depth video on YouTube. Under Set All Actions, I'll first switch everything to None, because for this demo we only want to export selected drawings. For example, the assembly drawing, then a welded assembly. I'll set that sheet size to DIN A1. For welded assemblies, you can also pick the desired views here on the right. Then let's add one plate, the end plate, with A4 sheet size, and one of the large beams on A3. That should be enough. Now we choose the export path for the drawings. Enter an order number, and start the export. The selected drawings are now being exported. It takes a short moment, but at least you can watch the drawings being created in real time. Alright, export is done. Let's check the result. In the selected export path, a folder was created using the order number, and inside it you get subfolders by drawing category, which keeps everything nicely organized. Here's our profile drawing, for example. Let's open it. Now we can see all 4 views, and everything has been dimensioned automatically. Auto dimensioning isn't always perfect, but as usual you can move and edit dimensions with standard SolidWorks tools. Alright, that's it for shop drawings. Also in the Drawings menu, we have automated DXF export for plates. In the dialog, you can either select individual components or entire assemblies, and then all included plates are exported. Equal part detection applies here as well, so identical plates are exported only once, with quantity information. We assign an export name, and down here we can set options, like writing the quantity into the file name or including bend lines. Then choose a save path and start the export. During export, all plates created as extruded bodies are converted into SolidWorks sheet metal parts at the same time. Takes a short moment. Okay, now it's done. Let's check the result again. Here too, we get a folder named with date and time, containing subfolders sorted by plate thickness for clarity. In the 20mm folder, we should find the larger end plates. Let's open one in a viewer. Yep, there it is. Nothing impressive, just the geometry with the holes. What's impressive is the user benefit. With just a few clicks, you can export several hundred plates from large assemblies, neatly sorted and checked for geometric equality. That's enough on DXF. Now let's move to the newest available export function in SolidSteel parametric, the IFC export. In the dialog on the left side, we first define the save path. Then choose the IFC version, either the older IFC2x3 or the current IFC4. Below that, define what to export. I'll keep it at all components. Those settings are enough, so we can start the export. We can also confirm this message to achieve the most optimal export result. Export is quick with this small assembly, and we get a summary, for example, how many beams, plates, and fasteners were exported. Now let's open the result in a viewer too. Our soccer goal is now ready for a downstream BOM workflow. All details are preserved, really a great new addition to SolidSteel parametric's export capabilities. To wrap up, let's take a look at DSTV NC or NC1 export. For this, we use the DSTV Assistant add-in, which is available separately. Operation is very simple. I'll use Quick Start for assembly to analyze the full assembly in one go. And here's the result already, listing all identified profiles and plates. Of course, the DSTV Assistant recognizes all SolidSteel parametric parts like profiles and plates. But it works just as smoothly with data imported into SolidWorks as well, such as step files. Right-click, Export All starts the next step. In the dialog, we enter an order number. Then select NC or NC1 as file format, optionally deactivate or activate NC blocks below, choose a path, and confirm with the green checkmark. When the icons turn colored again, export is complete, and now we'll check the result. Again, we have a folder named with date and time, and inside are the DSTV NC files. Let's open one of the large beams in a text editor. This is what the NC data looks like. Here again, equal part detection ensured that identical parts are exported as a single file only. In the DSTV data, the required quantity is shown up here as 2. Below that are the NC blocks for contours and holes. Now let's also open the beam in a viewer. Here you can see the interpreted NC data, and this also worked perfectly. The HB240 is shown correctly with all holes. And that's it for today. As we've seen, SolidSteel Parametric and the DSTV Assistant offer a wide range of export options, covering not only pure modeling, but also the required subsequent processes. Thank you very much for your attention, and see you next time.